Welcome to Maths with Bob. Today we're looking at the 3-minute series in statistics. We're looking at hypothesis testing on the t-distributions. This is obviously where the populations, if you like, variance is actually unknown. We're going to do some inferences on the mean. Looking at a one-sided test, we're going to be using our t-statistic here. You can see here it's usual one, x bar, which is the sample mean minus population mean all over sample standard deviation of square root of n, n minus 1 degrees of freedom, sample size n. Right, okay. You can see here they're very similar to the normal distribution. Okay, so we're looking at the breaking strengths, the mean breaking strengths of rope actually. 6 are tested. They have a mean breaking strength of 7,800 newtons and the standard deviation 180 newtons, whereas the manufacturer actually has claimed a breaking strength of 8,000 newtons. Can we support the manufacturer's claim at a 5% level of significance? Okay, well, let's set up a test. Okay, null hypothesis, the mean is actually 8,000 newtons, and the one-sided test, which we're going to have a look and have a see if it actually is less than 8,000. Okay, when we plug it in, you can see here 7,800 minus 8,000 or 180 on the square root of 6. So we end up getting minus 2.722. Okay, which is actually a little bit down here somewhere. Okay, which is a little bit improbable, if you like. Okay, we're going to reject that 5%, but if we increase the confidence interval, drop the significance level down to 1%, if you like, you can see here it's actually 3.365. Now, just something on this, the t-distribution tables actually only give the positive values, which are up here. So because of symmetry, we just reflect it back down here and take the negative. So negative 3.365 would be down here somewhere, and our test statistic would in fact be acceptable at that particular level of significance. Okay, so what's happening? Well, our t-statistic minus 2.722 is in fact too improbable. Where is it? Here, let's see if I can bring it in. Grab it, hold it. This is it here, but I'm just going to try and grab it. Okay, let's have a look. Here we go. Here it is. So it's actually down here somewhere. Okay. And you can see here, we're going to, obviously it's not in the acceptable region, which is over here. So we're rejecting it basically. And you can see here that the mean breaking strength does not support the manufacturer's claim of 8,000 newtons. In fact, it's actually less. Anyway, but at a significance level of 1%, okay, we can actually, which is reflected down is minus 3.365, we can actually accept the null hypothesis that the manufacturer's claim is in fact 8,000 newtons. I'd be more inclined to look at the 95%, okay, at the smaller confidence interval, okay. Anyway, well, thank you for watching and bye for now.